Okay, so today we're going to learn about the chain rule, and it basically pertains to composite functions that look like this. So you have y equals f of g of x, which is basically the composite function. Basically what that means is the function f of x is dependent upon the value of the function g of x overall in the overall equation. So to apply the chain rule is when we take the derivative of f of g of x, which looks like this. So the derivative of f of g of x equals f prime of g of x multiplied by g prime of x. So basically, it's the outside of the function, which is f of x, times the inside of the function. So the derivative of the outside, f prime of g of x, times the derivative of the inside. Okay, so for our first example, we're going to find the derivative of this equation, which is y equals x squared plus 1 cubed. So the outside function, which is the f of x, is the cubed part, and the inside function is g of x. So to take the chain rule, basically the first thing you're going to do is take the outside and you use your exponent rule. So you do y equals 3 times, so this is the outside times the inside, so you leave the inside the same, x squared plus 1, and then squared, right? So that's the outside. This, you multiply it by the first, you multiply the exponent by the front of the function and then subtract 1 and keep the inside the same. And then we multiply it by the inside of the function, so the g of x part, and that is 2x. So then overall, your overall equation, when you simplify it, is 6x times x squared plus 1 squared when you combine this term with the front term, and that equals y prime. Okay, so for our second example, we're going to find g prime of t when g of t equals -7 divided by 2t minus 3 squared. So we're going to rewrite this function to make it easier to take the derivative of it. So basically we're going to do g of t equals -7 times 2t minus 3 to the -2, and the -2 denotes that it is in the denominator. So once again, the first thing that we're going to be doing is taking the derivative of the outside, which is the exponent. So you multiply the exponent by the variable up front and then subtract 1 from the exponent. So when we do that, we get 14, because negatives cancel and 2 times 7 equals 14, times the inside, which is 2t minus 3, that stays the same, and then we subtract 1, which means this would become -3 up here. And then we multiply by the inside of the function, the derivative of the inside, which would just be 2. When you take the derivative of this, it just becomes 2 because the t goes away, and then any constants go away. So then overall, you get, when you simplify it, g prime of t equals 28, because that's 14 times 2. And then when we move this section into the denominator, you get 2t minus 3 cubed. So that's the answer to this. Okay, so for our third and final example, which is a little bit more challenging, we're going to find y prime for y equals cosecant of 2x plus 3 to the 4th power. So basically this one, instead of having 2 steps, has 3 steps, because we have the cosecant that we need to take derivative of, we need to deal with the exponent, and then we need to deal with the inside function. So the first thing we're going to deal with is the cosecant. So the derivative of cosecant is negative cosecant x, or whatever is inside, times cotangent x, or whatever is inside. So negative cosecant, and then we keep the inside the same, 2x plus 3, and we keep it also to the 4th, times cotangent 2x plus 3 to the 4th. So all of that stays the same. Then I'm going to move down here since I've run out of room, but we multiply that by the next step, which we will be doing the exponent part. So since we've already taken care of this, we can just ignore it and we just deal with this section. So it would be 4, because we moved the exponent to the front, multiplied by the front, 2x plus 3 to the third power, right, because we subtract 1. And then for our final step, we need to multiply by the derivative of the inside of the function, which is just 2, since the x goes away, and so does the 3. So when we simplify all of this, you get y prime equals negative 8, because 4 times 2, and then the negative, that's where the negative 8 comes from. And then 2x plus 3 cubed, getting rid of this part of it. And then we have cosecant 2x plus 3 to the 4th times cotangent 2x plus 3 to the 4th. And that's how you do a more difficult chain rule problem.